find the number of permutations x1 to x5 of the numbers 1 to 5 such that the sum of 5 products given by this expression here is divisible by 3. Okay. So some permutation of the numbers 1, 2, 3, 4, 5, and this expression it's basically every sort of three-way circular product. We want that to be divisible by 3. And we need the number of ways that we can do this. So how many permutations are there? There's only 120. So one thing to note, let's say x1 is equal to 3. Then I don't care about that or that or that. Those will automatically, those 3 individual terms will automatically be divisible by 3. So here I'm left with x2, x3, x4, and x3, x4, x5. So I think what we want to do is suppose x1 is equal to 3. Okay, and of course we'll solve the problem. We'll count how many permutations there are when x1 is equal to 3, and then I believe we'll just end up multiplying that by 5 because there are 5 total x's that could be assigned the number 3. So then the term I'm concerned with now is x2, x3, well, hold on, why don't I do it, why don't I suppose x5 is equal to 3? x5 is equal to 3. Then I want x1, x2, x3 plus x2, x3, x4. I want that to be divisible by 5. And this is equal to x2, x3 times x1 plus x4. Okay. And the digits that I have left, or the numbers I have left to assign, are 1, 2, 4, and 5. So that's not divisible by 3. That's not divisible by 3. But this sum might be divisible by 3. But the only way to do that, well, there's a few ways to do that, right? x1 and x4 could be, these could be 1 and 2. They could be 1 and 5. They could be 2 and 4, or they could be 4 and 5. So how many ways are there here of doing that? So how many, how many pairs work? So x1 and x4 can be equal to 1, 2, 1, 5, 2, 4, 2, 5 does not work. 4, 5 works. And of course all of the all the ones in the opposite order like so. Is that all that there are? 1 can be paired with 2 or 5. 2 can be paired with 4, and that's it. 4, we've already paired it with 2, it can be paired with 5. Yeah, so if x5 is equal to 3, I count 8 ways. Oh, but I also have to keep in mind that these can be flipped around. I can, you know, if there are 8 pairs, 8 permutations of these two things that can work. And for each one of them, there's 2 assignments of x2 and x3. So suppose x5 is equal to 3. How many ways are there? 16. So I have to do 16 times 5. 50 plus 30, which is 80. So this is going to be my answer. There's 80 ways of doing it. 80 permutations of these numbers such that this product is divisible by 3. Yeah, I mean, I hope this is correct. If it's not, I'll let you know. But I think there were kind of 2 important insights here. First, only 2 of the terms actually could matter here, because no matter what permutation of these numbers you have, the number 3, and think it's because of, you know, prime factorizations of things as well. The number 3 in this list is the only one that has 3 as a prime factor. So if you want this whole thing to be divisible by 3, if a factor of 3 appears in any of these, that term doesn't matter. Okay, and so of course for any permutation, the number 3 appears in 3 different of those terms. And then, you know, factoring out x2 and x3 here, realizing that neither of these can possibly be divisible by 3, given that we've already assigned it. So you need that to be a multiple of 3. And how many ways can you do that? Well, 8. And, you know, don't get mixed up. You don't remember to keep in mind the permutation of just these 2 numbers here. So yeah, I think I'm not like an expert on combinatorics. I often find myself doing problems like this and overcounting or double counting or undercounting. So I hope I didn't mix up any of the logic here. But like I said, I'll let you know what the right answer is if this is not correct. Thanks for watching.